Welcome to Mrs. Miller's notes for her double block algebra class. These are the notes for section 4.5 entitled Slope of a Line. And what we're going to do today is find the slope of a line. And first we're going to take a moment just to think about what slope is. And slope is actually how steep something is. And you can see slope out in the real world in all kinds of places. You can see it in hills. If you think of skiing, you could think of it in roofs. Some people are having their roofs repaired from hail damage, so some people have steeper roofs than others. Some buildings have completely flat roofs, like the school. You can see it in ramps, like a wheelchair ramp that goes into a building, or maybe a ramp that's coming off the back of a truck to load and unload the truck. So those are just some brief examples, but slope is definitely something that we can see in the real world. Now, when we're dealing with it on a graph grid, we can find the slope of a line on a graph in a couple of different ways. We can count it, meaning we can count the rise and the run between 2 points on the line, or we can use a slope formula. And you'll get the same answer either way. Sometimes it's more efficient to count if you have the graph and the line and 2 points that are close together. Sometimes you're just given 2 values, and taking the time to make the graph and count would take more time than actually using the formula. But we're going to take a look at both. So the first method for finding slope is to actually count. Now, when we count, we're counting how much we're rising, the vertical rise, so that's on our y-axis, over the horizontal run, and horizontal is our x-axis. And the variable they use for slope is m. I think it comes from the Latin word modulus. I'm not sure why the old dead math people decided to use that word or to use the variable m for slope, but that's the variable we use. So in example 1, we're going to plot these points first, and then we're going to count the slope between the points. So for part A here, we have the point 1, 5, and then 9, 0. So I'm going to plot 2, 3, 4, 5, 1, 5, and then 9, 0. And actually, I could connect them with a line if I wanted to. And I'm going to take a moment and I'm going to connect the other points in part B first, just so I have all my points plotted before I start talking about the slope. So we've got 1, 2, and then 10, 5. Okay. So there are my points and the line that they are on. Okay. Now, to find the slope, I'm actually going to start with part B here. I want to count my rise over my run. Now, the rise is how much we're rising on the y-axis. So you can think of this in a couple different ways. If I look at a graph, remember we read a graph from left to right. So the first point I come to on the left is right here. And that had a y value of 2. And then my next point had a y value of 5. So I'm actually rising 1, 2, 3 units. So my rise is going to be 3. And then to find my run, I'm going to look on the x-axis, the horizontal run. So again, the first point is down here at 1. And the second point was down here at 10. So to go from 1 to 10, I'd have to go 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. Now hopefully you did that faster in your head. Hopefully you did 10 minus 1 is 9. But then to find my actual slope, I need my rise over my run. So 3 over 9. I'm going to write it like a fraction. And I do want to reduce that to 1/3. So my slope for this line is going to be 1/3. And we can see this if I start at the first point and I go up 1 and over 3, I land on the line. Up 1 and over 3, I land on the line again. Up 1 and over 3, oh, I get to my final point. Okay? So those are how many whole units or little graph grids or how many lines you're moving up and then over to go from one point to the other. So now let's go back to part A here, because this slope looks a little bit different. My rise this time isn't actually a rise. Okay? But if I go from left to right, the first point that I come to is right here. And on my y-axis, it has a value of 5. And my other point on the y-axis has a value of 0. So that's 1, 2, 3, 4, 5. But I'm not actually rising. I'm going down from left to right. So this rise isn't really a rise at all. It has a negative value. So it's kind of like we're falling. But we still refer to it as rise. We just put the negative in front to show the direction that we're going. And then my run, I'm going to look from left to right. My first point comes down here on the x-axis. So that was 1. My second point is actually on the x-axis at 9. So to go from 1 to 9, you could count or you could subtract. That's going to be 8 spaces. So my actual slope then, m, will be -5/8. And I can't reduce that. So that is my slope, -5/8. So again, that means that from my first point, I would go down 5 units and then over 8 units. And I go right from the first point to the second point that I plotted. And that's because I didn't reduce at all. I couldn't reduce my fraction. Now, there were a couple times where I said, oh, when we're calculating our run, we have to go from 1 to 10, and we could count that that's 9 units, but hopefully you did the math in your head that that's 10 minus 1 is 9. And that's actually what you do. You take your x value of 10 and you subtract your other x value of 1, and 10 minus 1 gets you the 9. And that works for the x values as well for your rise. We had a rise here of 5, and then here the other value was 2. So from 5 to 2, if I subtracted those, that got me 3. So this is where the actual slope formula comes from. We subtract our y values, and then we subtract our x values. Now the 1 and the 2 don't really matter in terms of which ordered pair you call x1, y1, and which ordered pair you call x2, y2. What the 1 and 2 mean is that order matters. And we're subtracting here in our formula. So you should know that order matters for subtraction. So the order that we go in when we're subtracting our y values has to be the same order that we go in when we're subtracting our x values. So for part A, we could take 2 minus 4 and 3 minus 8, or we could do 4 minus 2 and 8 minus 3. It doesn't matter which order you go in, you just have to go in the same order for both the x's and the y's. You can't flip-flop. So I couldn't do 2 minus 4 and then 8 minus 3. So that's what the 1 and the 2 mean there. But again, this y, that's going to be the change in our vertical. And the x's, when we subtract them, that's going to be the change in our horizontal. So it's just like we were doing before. We were counting our rise over our run. So now we're going to use this formula to find the slope between these points. So for part A, I have 2, 3, and 4, 8. And if you need to, label your ordered pairs, x1, y1, x2, y2. I like to call the first ordered pair x1, y1 because it comes first. the second ordered pair, x2, y2, because it comes second. But again, it doesn't matter which way you label them as long as you're consistent. All right, so then my slope, remember we used the variable m, equals. So now I have to subtract my y values. So 8 minus 3, y2 minus y1, and then I subtract my x's. And I have to go in the same order. If I started with 8 minus 3, now I have to do 4 minus 2. So 8 minus 3 is 5, and 4 minus 2 is 2. And I can't reduce that anymore, so I'm going to leave it. Do not write it as 2.5. We do not write our slopes as mixed numbers. That's bad. Don't do that. We want to leave the slope as a fraction because this number represents our rise. We have to rise 5 units, and then the bottom number represents how much we run. We have to run 2 units. If you write it like a mixed number, I don't know how much I'm rising or how much I'm running. That doesn't make sense in terms of slope. So I know 5 over 2 as a fraction is equivalent to 2.5, but I want to leave my fractions now as improper fractions because they're not just fractions, they're representing a distance so that we can move on a graph. Okay, for part B, we have 3 and negative 2, x1, y1, and then 1/6, x2, y2. So if you need to, label your ordered pairs. Now here I have a minus and negative 2. So remember, that's going to be a plus, a positive. Then I have 1 minus 3. So 6 plus 2 is going to be 8. 1 minus 3, that's going to be a negative 2. Now this I can reduce, and this will be negative 4 over 1. Now we want to keep the negative in the numerator because that tells us if we're going up or down, if the line is going up from left to right or down from left to right. So I know the negative was here in the denominator, but we want to move it up to the numerator. And leave it over 1 because, again, I know negative 4 over 1 is equivalent to negative 4, but we need this fraction because the negative 4 tells us how many we're moving down on the graph, and the 1 tells us we're moving over 1. Okay, 2 more to practice. I have negative 2, so x1, y1, and then 3, negative 2, x2, y2. Label those ordered pairs. There's no shame in doing that. Labeling them will guarantee that you get the right number into the right spot in the equation. So now I have negative 2 minus a negative 2, so that's going to be a plus a positive 2, all over 3 minus a negative 2. So again, that's another plus a positive 2. And my numerator, negative 2 plus 2 is going to be 0. And then 3 plus 2 is 5. Now 0 over 5, that reduces all the way down to 0. You can have a slope of a line that is 0. That means you're not rising at all. If you have a 0 here in your numerator, that means you're not rising at all, but you are running. So try and visualize that. What kind of a line wouldn't rise at all? It wouldn't go up or down, but it would go left and right. That would be a horizontal line. So horizontal lines will always have a slope of 0. And remember, we graph horizontal lines with the equation y equals some number. Okay? And a good way to remember this is that horizontal has O's in it, and 0 kind of looks like an O. So horizontal lines have a slope of 0. That's a good way to remember that. And then for part D, this one might be another special case too. Let me label my x1, y1 there on the negative 3, 2, and my x2, y2 on my negative 3, negative 5. I'm going to substitute them into the formula. Negative 5. Oops, not plus 2. There we go. Negative 5 minus 2 all over negative 3 minus a negative 3, so that's going to be a plus 3. plus a positive 3. So negative 5 minus 2, that's negative 7. Negative 3 plus 3, that's 0. Now, can you divide by 0? If you're not sure, try it out on your calculator. Take negative 7, divide it by 0. Your calculator is going to give you an error message. And that's because this slope is undefined. We cannot divide by 0. You can't take 7 things and turn them into 0 things without destroying them or crumpling them up, throwing them away, or eating them. Okay? You cannot divide 7 things into 0 parts. So think of what this means now. This means that this line has a rise, or in this case, it's negative, so it's falling. It has a rise. It doesn't run at all. So try and visualize that. What kind of a line would it be if it goes up or down, but doesn't go left or right? That would be a vertical line. So anytime you have a vertical line, it's going to have a slope that is undefined. And remember, when we graph vertical lines, they're x equals some number. That's how you write the equation for vertical line. Okay, so please don't say that negative 7 divided by 0 is 0. It's not 0, it's undefined. So those are a couple special cases. So we've taken a look at 4 examples here where we had a positive slope, we had a negative slope, and then we have a 0 slope, and then an undefined slope. So those are the 4 kinds of slope that you can have from lines. Okay, our last example then is a word problem. It's a small one. It says the roof on a building rises 4 feet for every 50 feet of horizontal distance. What is the slope of the roof? So we know we're going to have our rise over our run. So it says that it rises 4 feet for every 50 feet of horizontal distance. Now, does that mean it's running? If you're going horizontal, you're going left and right. That's that running concept. So we are going to have 4 over 50, and that I can reduce to 2 over 25. So that would be the slope of that roof. And they don't really call a slope of a roof slope. They call it pitch. So if you're familiar with that construction term, that's what slope is in construction terms. They don't call it slope, they call it pitch, the pitch of a roof. Okay? So you will see some word problems like that in your homework as well. And remember, we talked about there being 4 kinds of slope in our last example. You can have positive slopes, you can have negative slopes, you can have a slope that's 0, or you can have a slope that is undefined. So you're going to see all 4 of those in your homework tonight. So there's your set of problems to practice these concepts. And if you have any questions, come on in before school and see me.